Okay, you all were tasked to annotate chapter 1, and I got some good questions about the when sub-chapter that deserve an answer, so I just want to rattle these off and make sure that when I get to that slide that I address these questions, which will be highlighted in red. So I got good questions about off-the-shelf devices, if they're made with spacecraft in mind, to cater to a market, or is the field of spacecraft design growing so fast that these components are necessary for faster development. And then I got a question about rocket development and its correlation to world wars and the economy. There's another question about the Soviet Union and their management of funds for the space program. Then I got a question about different tiers of funding at NASA. And then a question about Explorer 1, and then Voyager 1. And then some clarifications for the textbook. So we got an annotation about if the first reusable crewed orbital spacecraft is also the Space Shuttle program. And yes, it is. The reason why it's labeled first reusable crewed orbital spacecraft is because when we're recognizing these unprecedented feats, we just need to qualify in what way is it unprecedented. But yes, they are one and the same. And then also the USSR was on track to win the space race given its initial space feats, but ultimately did not. The definitive moment was when the US landed Armstrong on the moon. Okay. So many of you will recognize this set of slides. I have modified them since EPET 301, but because I didn't record it during EPET 301, you all have the opportunity to watch it a second time. So today we'll be discussing the first subchapter of chapter 1, which goes over the history of spacecraft missions. So I'll start with before BC was a thing. We've long had observers way before we've had space travelers. Our longing to explore space is inextricably linked to astronomical observations, documented famously by Ptolemy, Aristotle, Copernicus, and Galileo. On the left, we have Hypatia of Alexandria, who was a philosopher, astronomer, and mathematician. And the reason why I put her in there is because, you know, ladies don't get enough credit throughout history, so just shout out to Hypatia. International events leading to space exploration pre-20th century include, I'm just going to pause for 1 second. Okay, so where was I? International events leading to space exploration pre-20th century include telescope observation, theorizing the rocket equation, and proposing the space elevator. And the minds behind these innovations were actually authors and other scientists. So that kind of imagination spurred on that, I guess, look behind our atmosphere. A golden age of science fiction played a huge role in inspiring and proposing innovative and sometimes scientifically feasible ideas to explore space. Science fiction stories and films such as George Pal's Destination Moon, written by Robert A. Heinlein, helped to convince the tax-paying public that spaceflight was not only possible, but desirable from both a political and economic point of view. So here's a poster of the movie that was made about Destination Moon and a shot from the movie itself in black and white on set. Okay, a good chunk of time that we should talk about is World War II. World War II was a major catalyst in progressing rocket technology as the US, German, and USSR governments pooled their resources to develop missiles. The wealth and productivity of a single inventor or group of scientists pales in comparison to the wealth and urgency of a nation in wartime. The first spaceflight, which we qualify as the first crossing of the Kármán line in history, was achieved in June 20th, 1944 by the V-2 rocket under the direction of Nazi Germany and Dr. Wernher von Braun. This is the V-2 rocket, and there's Dr. von Braun. standing with some Nazis, but also in a car with JFK. So he's got an interesting life. The reason why he's sitting there with JFK is because upon the resolution of World War II, von Braun surrendered to the Americans in Bavaria. And for 15 years after World War II, von Braun worked with the US Army in the development of ballistic missiles. The picture on the left is that first space research flight. And then you know a little bit about his life on the right. Oh, and if it's not clear, you can ask questions in the chat, or you can unmute yourself and ask me anytime. So immediately after the resolution of World War II, with the strategic capture of the leading rocket expert of the world and many other German specialists, the US begins to dominate unprecedented aerospace achievements from 1946 to 1956. We got in the bag the first space research flight, first pictures of Earth from 105 kilometers, the first animals in space, of which the first animal was a fruit fly, the first two-stage liquid-fueled rocket with an altitude record, and the first rocket to pass the thermopause and enter the exosphere, which are different outer layers of our atmosphere, and we'll cover that in our space environment chapter and lectures later on in the semester. So on the left here is the first photograph of Earth ever taken from space. It was captured on the 24th of October, 1946, from a rocket 105 kilometers above ground that had been launched from the White Sands Missile Range in New Mexico, USA. On the upper right is space pioneer Miss Baker, a squirrel monkey. I guess she rode a Jupiter ballistic missile into space in 1959. And then here's the first spider web built in space. This is funny. I just think that we as a global community have sent a lot of animals to space. We have this fascination with it. There's a very long Wikipedia article on this. I think one of the most amusing videos was a cat trying to right itself in space, but in space there's no gravity. So it's just like turning its angular momentum all over the place. Okay, the Cold War is the next significant chunk of time where things happened, and there are a lot of questions here. So I'm going to go over my little spiel and then answer these questions. The Cold War began in 1947, which fostered an ideological tension that led to the technological arena for competition, the space race. Both the US and Soviet governments had prioritized the development of intercontinental ballistic missiles, which is another way of saying weaponized rockets, which was ultimately won by the USSR that sent the first ICBM R-7 into space. The demand for intelligence gave rise to overhead reconnaissance programs, which began as U-2 overflights, but transitioned to reconnaissance satellites. U-2s are very, very fast, high-altitude airplanes, or jets. Thus began the race to send the first satellite to space, which was ultimately won in 1957 by the USSR in their launch of the first artificial satellite Sputnik 1 and the first biological spacecraft Sputnik 2. You'll see on the upper right, that is Sputnik 1, but Sputnik 2 looks very similar. The difference is that Laika was inside, this dog. So in response, the US formed the National Aeronautics and Space Administration, which you all know as NASA, and just 3 months later, NASA launched their first satellite, Explorer 1, into orbit. On the bottom left, you'll see the Vostok family of rockets, of which R-7 was first in the family. The Sputnik launcher is the second rocket in this lineup. Sputnik can be seen in the top right. It is the simplest satellite that blinked, "Here I am." This is the first satellite ever in space. What I want you to notice as we move forward are how the subsequent spacecraft look. On the bottom right is the Romanian stamp from 1959 with Laika, in which the caption reads, "Laika, first traveler into cosmos." In November 1957, Laika became the first animal launched into Earth orbit, paving the way for human spaceflight during the upcoming years. Okay, so we have some questions here from the first chapter. The first question is, so essentially the rocket would have taken much longer to have been successful if there was no World War II, since there was the Great Depression. And I wouldn't say that the strongest correlation to the progress of rockets was the economy. That is certainly a good correlation, but it's also political wins. So at the time, World War II was well, any war is a huge defense effort, and rockets were part of this defense technology. So yes, I think this argument would have been even more bolstered if we had a good economy and we had a war. But because of this unique situation of having a Great Depression and a war, having a war helped us out of this Great Depression and helped us in building rockets faster. What were the features that Explorer 1 had, such as what kind of reconnaissance could it achieve? So Explorer 1 was very similar to Sputnik. It had a little bit more than just a blink to tell the world that it was alive. It had some science instruments that were measuring micrometeorite impacts, and I think some other science, but it didn't actually have reconnaissance per se on it. I think it progressed what we would call reconnaissance in that it was a proof of concept that we could send a satellite into space, which can be used for reconnaissance. Now, today, we have a space agency called the National Reconnaissance Organization, the NRO, which is dedicated to just spy satellites, essentially. I don't talk about it that much, but I can talk about it later when we think about defense and how it's a decade more technologically advanced than civil science, for example. Actually, I'll just talk about it here. The NRO, the National Reconnaissance Organization, donated a telescope that was of the quality of Hubble, but it was declassified. So it took maybe a decade to become declassified and to be donated. So that tells you a little bit about how the NRO was just keeping this state-of-the-art technology in their warehouse for a while when civil science had just gotten to catch up. And the reason for a lot of this technological progress is funding, I would say. The NRO, I don't know the exact numbers, but the NRO has a lot of funding to do a very specific task, whereas NASA has the same or less funding to do a broad range of science. Okay, and the last question on this slide is it meant to be implied that the Soviets diverted funds from their space programs to their defense budgets, causing them to lose the race to put a human in space? I wouldn't say, I don't know how much of this is true. The Soviets put a lot of funds into their space program, but I don't know about their defense budgets. I don't think they have a defense spending complex as much as America does. And I don't know if, well, first of all, I don't think they diverted funds from their space program to their defense budgets. And further, I don't think that that's the reason that caused them to lose the space race. I think it was just a matter of, two countries having very intelligent people that were developing technology around the clock, and then one of those countries won. Okay, hopefully I answered those questions okay. If you're still unsatisfied, please put questions in the chat. Okay, so as we alluded to, there was the race for the first man in space. The next obvious title to seize after putting the first satellite in space, which was an artificial piece of metal, was the first human spaceflight. And this was won by the USSR for sending the first cosmonaut, Yuri Gagarin, to space. Yuri is seen in the left. Not even a month later, NASA sent Alan Shepard to space. Alan Shepard is standing in front of a Mercury command module that he would have to sit in for a flight of 15 minutes from launch to landing. Then we'll talk about a succession of firsts. In the decade of 1960, we saw the first solar and interplanetary satellites and probes, the rise in geosynchronous communication satellites, but prominently featured advances in human spaceflight around the moon. Pioneer 5, also known as the paddle-wheeled satellite, was a spin-stabilized space probe in the NASA Pioneer program used to investigate the interplanetary space between the orbits of Earth and Venus. The USSR had Luna missions. So we got a question in the chat. Didn't the USSR put a human into space first? Meaning they were the first country to put someone in orbit? Yes, that is true. The nuance here is that the USA put the first human on the moon. And that was a defining moment. So the USSR was leading the space race up until Armstrong got to the moon. Sorry for the ambiguity. Okay, so yes, to get to this moment, this momentous point in history, the USSR had the Luna missions and the US had the Mercury, Gemini, and Apollo missions for human spaceflight. Apollo 8 released the famous Earthrise photo, which is seen on the left. The most famous lunar mission, Apollo 11, sent the first human to the moon's surface and saw the first launch from a celestial body other than Earth. So here's Armstrong on the moon's surface. And in that same mission, what we mean by the first launch from a celestial body is that they had to take the Lunar Command Module, which had landed on the moon's surface, and to send it back into orbit. We returned 22 kilograms of moon samples from this mission, contributing heavily to the planetary science field. In subsequent missions from 1969 and 1972, the Apollo missions returned 382 kilograms of lunar rocks, core samples, pebbles, sand, and dust from the lunar surface. For various reasons, the USSR failed to dominate the race to the moon, despite its very early and promising progress. US spending and arguably activity peaked during the Apollo program. So this is the Earthrise photo. Here's Buzz Aldrin from Apollo 11. There are some samples from Apollo 11. And then this is Commander Pete Conrad with Surveyor 3 with the lunar module Intrepid in the background for the Apollo 12 mission. Oh, and I also put Apollo 13's mission patch on here because it's one of my favorite. I think it's just really beautiful. And it's a tradition that a lot of space missions have to create a mission patch with every mission. Okay. So next we see broadening participation around the globe. In the 1970s, the narrow lunar focus brought in to incorporate the other planets. First to our nearest neighbors, Venus and Mars, then to Jupiter and Mercury. In 1975, we saw the formation of the European Space Agency and a surprising collaboration between the USSR and USA in the first multinational manned mission, Apollo-Soyuz test project, amidst the ongoing Cold War. NASA continues the attitude of international collaboration with Germany's DLR on Helios 2 and ESA and UK's CIRC on the International Ultraviolet Explorer toward the end of the decade. DLR is Germany's space program, CIRC is UK's space agency, and then ESA is the European Space Agency. NASA also makes an unprecedented successful planetary surface landing on Mars, sending back the first photos from the surface of Mars through the Viking lander, which you can see here. This is the Apollo-Soyuz collaboration mission patch. And then here is a technician standing next to one of the twin Helios spacecraft. And then here is the International Ultraviolet Explorer, an orbital ultraviolet observatory. Okay, now we'll talk about persistent space structures which are space objects that stay in space, interplanetary missions, and the first spacewalks. So the 1980s saw the rise of persistent space structures, such as the first reusable crewed orbital spacecraft, which is Space Shuttle over here, the first infrared and microwave observatories, the first consistently inhabited long-term research space station, and we also are seeing more sophisticated interplanetary missions, such as the first balloon on another planet, Venus, the first Uranus, Comet, and Neptune flybys. And then finally, we're also seeing spacewalks. The first untethered spacewalk, which is shown here, and the first spacewalk by a woman. So these pictures, the first row is showing the shuttle, the first infrared observatory, the first microwave observatory to explore the cosmic microwave background radiation, and the beginning of the International Space Station. On the bottom row, we are seeing the Vega Solar System probe bus and landing apparatus, the Voyager 1 illustration that flew by Jupiter and Saturn. And this is also what Voyager 2 looks like, which flew by Jupiter, Saturn, Uranus, and Neptune. And then here we see Bruce McCandless on the first untethered spacewalk. And this is Valerie, shoot, I don't have her name in my notes, but she's the first woman to do a spacewalk. Okay, there was a point in history that I think defined or pivoted the way that we approach space. And I would say that's the Space Shuttle Challenger explosion. So in 1986, America suffered a devastating loss of the Space Shuttle Challenger, a formative memory of the US space program. Challenger hosted many cultural firsts: the first American female astronaut, Sally Ride, the first African-American astronaut, Gwion Bluford, the first Asian American astronaut, Ellison Onizuka, who is from Kealakekua, Hawaii. Although American attitudes shift towards a net positive assessment of the benefits and costs of space exploration, the Space Shuttle program would change drastically to reduce the effectiveness of the program by exerting extreme caution. So we saw less civilian launches, we saw satellite launches shifted from space shuttle operation to reusable rockets, and we also imposed more caution on the astronauts who were doing spacewalks, although they still happened. So I'm just going to play a quick clip of this happening.
T-minus 21 seconds, and the solid rocket booster engine gimbal now underway.
It's beginning throttling down now at 94%. Normal throttles for most of the plane, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs.
So I hope you all can hear this.
Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles.
So the 25th Space Shuttle mission is now on the way after 4 delays that NASA cares to count. This morning, it looked as though they were not going to be able to get off.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
So when this was happening, the flight director and the mission operations crew, you can hear that they go silent.
Solid rocket boosters blew away from the side of the shuttle in an explosion.
And they're trying to figure out what happened to assess if the astronauts survived or not.
Looking very carefully at the situation. Obviously a major malfunction.
And I think what's interesting about after this is that this event was televised in such a public way that we didn't really see space missions or space activity publicized in the same way after this. I think there was a bit of trauma that held us back from, being proud of activities like this. Recently, SpaceX and
We're awaiting word they're
other space companies have, gotten more comfortable publicizing their activities, even in the face of failure. So you can see here why that was such a pivotal moment in the way that, America views our own space activities. Okay, so right before or around when most of you were born, Voyager 1 is on its way out of the solar system, although Voyager 1 won't leave the influence of the sun until 2012. So yes, it is out of the solar system by now, and Voyager 2 was soon to follow in 2018. Voyager collected imagery, the first photograph of the whole solar system, which can be formed at the start of 1990. So here is a very famous picture that is called the portrait, Voyager's family portrait of the solar system. As a result of a NASA-ESA collaboration, the Hubble Space Telescope is installed and is currently in operation, well known both as a vital research tool and as a public relations boon for astronomy. NASA injects its first spacecraft into Jupiter's orbit and successfully lands the first operational rover on another planet. This is on Mars. And then Japan contributes the first orbital radio observatory. Although not the first detection of an exoplanet, the first confirmed published discovery of an exoplanet is in 1992 by Canadian and Polish scientists Wolszkin and Frail. Frail. I wonder, Andrew, if that's why you have your username that way. Russia re-enters the efforts in space by recording the longest duration spaceflight. Russia, USA, Europe, Japan, and Canada participate in the first multinational space station and the largest artificial object built in space to date, the International Space Station, which is a terrific end to the millennium. So I'll just go over these pictures real quickly. This is Voyager's family portrait of the solar system. Here is Galileo, the first spacecraft to be injected into Jupiter's orbit. Here is an image of the Carina Nebula, which was taken by our beloved Hubble telescope. Here is Little Sojourner rover, which is the first operational rover on Mars. And that's the ISS, the International Space Station. Okay, from modern day history, from 2000 and onwards, this does not break as many technological records in quick succession as many technological firsts have been accomplished in early history. Russia seems not to participate in record breaking, although they continue to offer crewed space support for the ISS. NASA, ESA capture the spacecraft first for the remaining major celestial bodies. So for the first orbit of an asteroid, the first orbit of Saturn, the first soft landing in the outer solar system, the first orbit of Mercury, the first orbit of a dwarf planet Ceres, and the first flyby of Pluto. The US starts prioritizing sample return missions like solar wind particles and comet samples, and the identification of exoplanets through the Kepler Space Telescope. So I'll just go in order. This is the first orbiting of an asteroid called Near Shoemaker. This is the first orbiting of Saturn and the first soft landing in the outer solar system. This is Cassini, and on it is a probe called the Huygens probe. Here's the first orbit of a dwarf planet Ceres, the Dawn spacecraft. Here is the first orbit of Mercury with the spacecraft Messenger. Here is the first flyby of our dwarf planet Pluto, the early concept art of the New Horizons spacecraft. And then here is the Kepler Space Telescope, which mission is to identify exoplanets. Okay, almost done with history. In Your Lifetime Continued, these are more recent missions. Japan contributes the first sample return of an operational rover on an asteroid. Many innovative space missions remain unmentioned, like instruments in the ISS or the multiple missions to the Moon and Mars, as they do not break records. But generally, the recent trend for spacecraft technology is to accommodate ambitious science missions and payloads. We also see a rise in commercial space dominance around rockets, distributing the responsibility of spacefaring from governments to private companies. Finally, we see the lightning-fast entrance of the Chinese government in sending spacecraft to the far side of the Moon, with the Chinese Space Agency budget implications towards even more space involvement. I'll also mention that India sent a rover to the Moon. So real quickly, this here is the sample return mission of solar wind particles, the Genesis mission. This is an artist's impression of stardust at Comet WWII, which collects comet dust samples. Here is a family portrait of different rovers on Mars. And then here's the first panorama from the far side of the Moon by the Chang'e 4 lander with the U-2 rover. Okay, on NASA, you can see the current landscape of spacecraft missions that are separated into different categories like universe, planetary, solar, and Earth. What I want you to know is that there are these wonderful posters that show you missions that are currently in formulation, in implementation, in primary operations, and then in extended operations. Let's see. This particular poster focuses on missions observing the universe. I request that you look at these on your own time because we're running a little short on time. But if you go to the lecture slides, the link is in the title. Here are the current planetary missions, for which we have many spacecraft on the Moon and Mars. I'll just pause here for you to observe the spacecraft body with respect to its orbital location in the solar system. One general trend that I'm seeing is that we spent a lot of time investigating Mars in the last decade or two, but we're seeing a resurgence in returning to the Moon. And there's a slide on that in a little bit. There are still celestial bodies in our solar system that we have not gone to, primarily moons of planets, of which Europa and Titan have the most interest. I think Enceladus is kind of underrated, so that would be really cool to see in our lifetimes too. Okay, here is the current landscape of solar missions. The reason why we study heliophysics is because it pertains to space weather, which is understanding how the sun affects Earth and the rest of the solar system. And then finally, we have NASA's Earth fleet. We have a ton of satellites that are orbiting our Earth, not to mention a ton of instruments on the ISS. Some of these are CubeSats, which are a type of small satellite. And I'll just mention here that HiTi is a satellite that the Hawaii Spaceflight Lab is developing in-house. Okay, so finally I want to talk to you about the push to return people back to the Moon and the first woman to the Moon. What started out in the Trump administration will most likely continue in the Biden administration. This program portfolio progresses exploration ground systems, the Space Launch System, Orion, which is the spacecraft that carries humans for lunar missions, the Deep Space Gateway, lunar landers, and Artemis generation spacesuits. The Artemis mission is an international human spaceflight program that is projected to cost $35 billion from 2020 to 2024. So I got a question about how the different tiers of NASA missions correlate with funding. And so I'll just say that the Artemis mission is a huge program that doesn't classify under flagship, New Frontier, or Discovery level. Flagship is the highest funding, New Frontier is medium, and then Discovery is smaller class. But Artemis is, a program on its own above flagship. Flagship missions are NASA's largest strategic missions. Historically, these missions are Voyagers, Cassini, the larger Mars rovers, the Europa Clipper, Hubble, James Webb, the Parker Solar Probe, Terra, and Aqua. Those are all flagship missions. For reference, Hubble costed about $5 billion, and the Europa Clipper is currently projected to cost about $4.25 billion. But Artemis, that's $35 billion. The New Frontier missions are medium class missions that further our understanding of the solar system. These missions include New Horizons, which is orbiting or flew by Pluto, Juno, which is around Jupiter, and OSIRIS-REx, which just had a very successful collection of samples from the asteroid Bennu, and then the planned Dragonfly Octocopter, which is going to go to Titan. And then finally, the Discovery level program has a lower cost cap than the New Frontiers program missions, but they are some heavy-hitting names like Shoemaker, the Mars Pathfinder, Lunar Prospector, Stardust, Messenger, Kepler, InSight, and Psyche. Okay, so I think that wraps up our history. I'm just gonna